Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Cik Hamid and my metric number is 01DPU21F1046.
Okay, water coil. Water coil are heat exchanger used in HVAC, heating, ventilation and air conditioning system for the transfer of heat between water and air. They are commonly found in various heating and cooling application within buildings. Jadi water coil ni merupakan salah satu komponen yang berfungsi untuk memanaskan dan boleh menyejukkan. Jadinya dia merupakan salah satu komponen penting lah bagi setiap bangunan. Okay, hot water coils. Hot water coils function as heat exchanger in heating. Hot water coils flows through the coils and air from the HVAC system is directed over the coil. Heat is transferred from the hot water to the air, warming the air before it is distributed throughout the building. Jadinya hot water coil ni dia berfungsi sebagai membebaskan udara panas lah. Jadi bila air panas melalui coil, jadi udara panas akan dibebaskan ke sekitar bangunan. Okay, for working principle of hot water coil is the coil is typically consists of a network of tube through which hot water circulate. Second, fin of or extended surface area often attached to the tube to increase the surface area for improved heat transfer. Last, as air passes over the coil, heat is conducted from the hot water through the coil and into the air. Okay, steam water coils. For heating coils, steam is the preferred medium for heat transfer throughout much of industry. It offers advantage over liquids because it is easy and inexpensive to move from the boiler to the point of use. Process control is easily and quickly accomplished with essentially no lag time as is experienced with liquids. The selection of coil construction and materials is a multi-step process that must take a number of factors into consideration. Armstrong's line of heavy-duty steam coils is designed and manufactured to provide the long life and efficient heat transfer that pays dividend over a long period of time. Jadi kalau kita tengok steam water coil ni adalah lebih efisien lah berbanding hot water coil. Okay, for working principle of water steam coil. Number 1 is fuel burning. Fuel like coal or gas is burned in a boiler to produce high temperature gas. Number 2, boiling water. Water is heated by this gas, turning it into steam. Third, steam pressure. The steam is at high pressure and carries a lot of heat energy. For the number 4, turning a turbine. The high pressure steam is directed at turbine blades, making them spin. Next, generating electricity. Spinning turbines blades are connected to a generator, creating mechanical work that turn into electricity. For the number 6 is condensation. The steam now at lower pressure is condensed back into water using cooling methods. Last is repeat cycle. The condensed water goes back to the boiler restarting the cycle. Type of coil. For the number 1 is high efficiency coil. A principal factor governing fin heat transfer efficiency is the boundary layer film of air adhering to any fin surface. This boundary layer insulates the fin, severely reducing the rate of heat exchange. The advanced ripple corrugate high-five design create a state of continuous turbulence which effectively reduce the boundary layer formation. The ripple film edge also strengthen the fin edge and provide a pleasing overall appearance. Okay, for the second is energy efficiency. The term energy efficient, which is used to describe how well a system utilizes energy, has become a common expression in the HVAC industry. Lowering the air pressure drop across the face of the coil will reduce the fan brake horsepower requirement and fan motor electrical demand. Okay, the type of coil for number 3 is standard coils, type S. This type of coil is used for most applications where adhering air temperatures are above 35 Fahrenheit and steam is at constant pressure. It is not, however, recommended where even outlet air temperatures are required immediately after the coil, such as in multi-zone heating systems or where a modulating steam control valve is used to control temperature. For the number 4 is centrifuge coils type C. The single-row centrifuge coil can be used where air is below freezing and or modulating control is used. A modulating steam control valve is used. Even outlet air temperature are required over the wool coil face stainless steel tube are used. Okay, for the number 5 is tandem coil type T and P. Freezing application requiring more than one row to achieve the desired final air temperature demand this type of coil. The coil is designed so that the total amount of steam to be condensed by the whole coil is fed into the first row in the direction of airflow. Dispersed non-condensable gas and droplet of condensate from that part of the coil exposed to the coolest air. Okay, steam circuiting arrangement. General purpose steam coils. Steam coils are specifically designed for economical general purpose heating, featuring high quality and high capacity. They are an ideal choice for all regular steam application heating, reheating, booster, and process use. The sectional diagram illustrates the steam circuiting of this single tube design. A perforated plate type steam baffle directly behind the supply connection ensures even steam pressure across the entire header length. Inlet tube orifice meter a uniform flow of steam into each tube. Okay, jet tube distributing coils. Jet tube steam distributing coils are excellent for any general purpose heating application. With the superior freeze resistance provided by the tube within a tube construction. They are ideal for low temperature preheating and special process application. The construction illustrate feature directional orifice inner tubes, a unique elliptical supply header located inside the heavy-duty return header and a circuiting arrangement which provide both supply and return connections at the same end of the coils. Okay, opposite end connection jet tube distributing coils. Jet tube steam distributing coils are very similar in design and operation to the JA coils except that supply and return connection are located on opposite ends. The directional orifice properly meters steam along the entire tube length to ensure a consistent temperature rise across the full coil's face and accelerate condensate removal. This important feature is standard on all of our jet tube steam distributing coils. Okay, for general specification, number 1 is primary surface 5/8 OD and 1 OD round seamless copper tubes. Cupro-nickel tubes are used for high pressure construction. Tubes are mechanically expanded to provide a continuous compression bond to the fins. For the second is secondary surface. Ripple corrugated aluminium deformed plate type fins. Fin collars are full drawn to provide accurate control of fin spacing and maximum contact with tube. For the three is headers. Extra heavy seamless copper tubing with extrude tube holes provide flexibility for uneven stress during coil expansion and construction. Cupro-nickel used for high pressure construction. For the number 4 is header and caps. Heavy gauge diforms copper monel used for high pressure construction. Okay, number 5 is connections. Steel mail pipes supply and return connection properly sized for coil capacity. Other materials available on request. Rat brace connections recommended for coils used with non-ferrous piping. For the number 6 is steam baffle. Supply header baffle depresses entering steam. Prevent below throw or short circuiting and ensure equal steam distribution to all coil tube. The number 7 is brazing. All core joints are brazed with copper brazing alloys. Headers have extrude tube holes which provide maximum brazing surface and ensure lasting strength. For the last is casing. Diform heavy gauge continuous galvanized steel with reinforced flange and 3/8 multiplication 3/4 slot on 6 center for easy mounting. Fin channels brace the core assembly in the casing, preventing air bypass and damage in handling.